Thank you for tuning in to Bite Size Science. I'm Dr. Tristan Brandhorst, and today we're going to be talking some more about fludioxonil, a pesticide that was originally postulated to work by a mechanism that would have guaranteed its harmlessness to everything besides the fungi it was designed to kill. We are talking about it because there's now ample evidence that it fails to live up to this ambitious advertisement. Yet this fungicide is still applied to many of the foods we eat every day. Fludioxonil was concocted by the agrochemical company Syngenta in 1993. They put forward the theory, at the time, that it functioned by acting directly upon a single enzyme, a kinase, that was unique to certain fungi. Now, if this were truly the case, fludioxonil would have been the ultimate antifungal, preventing mold spoilage without triggering the development of resistant strains while leaving crops and consumers unaffected. Unfortunately, recent research indicates that this is not likely to be the case. Limnologists, scientists who study the aquatic life present in lakes and rivers, have determined that fludioxonil is actually extremely toxic to freshwater plants, bacteria, algae, insects, and even fish. In fact, in many of these organisms, it has been reported to be what is called a Class 1 toxin. Note that there are no classes worse than Class 1. It defines those compounds that are decidedly life-threatening even in small doses. The fact that fludioxonil is found to be toxic in not only multiple species and even classes of living things, but that it has toxic effects upon representatives from more than one domain of life, is worrying to say the least, and certainly inconsistent with the commonly accepted, safe mechanism by which fludioxonil was supposed to work. A new piece was added to this puzzle when, in 2018, Dr. Stephanie Lawry determined that the mechanistic model of toxicity proposed by Syngenta was in error, and a mechanism based on a generalized induction of chemical stress appeared to be more likely. In 2019, Dr. Myrna Velke determined that a pesticide treatment containing fludioxonil was deadly enough to earthworms to be classified as a supertoxin, meaning less than 5 parts per million was enough to kill these beneficial residents of the soil. Studies found that when fludioxonil was mixed into topsoil such that it was protected from direct sunlight, the half-life of this pesticide was greater than 1 year. With such an extended lifespan in the soil, fludioxonil has the potential to build up over time even when it is only applied to crops once a year. This danger is multiplied, of course, if treatments take place more often than annually, which is often the case. Buildup of pesticide residues in the soil also means there is a greater chance for this type of toxin to migrate through the soil and reach the water table, potentially contaminating sources of fresh water there. As we mentioned, fludioxonil can wreak great havoc ecologically. Aside from the established threat fludioxonil poses to countless organisms in the natural world, one might also wonder whether a pesticide classified as a Class 1 toxin across so many species and classes of living things is really specifically harmless to our own species. It seemed to pass the EPA recommended toxicity tests in rats, but I would like to discuss 2 flaws with this approach. Firstly, fludioxonil is an incredibly hydrophobic molecule, and like most greasy, waxy, hydrophobic compounds, it does not dissolve well in aqueous solutions, like stomach acid. Our bodies have a mechanism to help us take up fats, however. We humans are quite good at absorbing fats from all manners of food, and this is because of an organ adjacent to our liver called the gallbladder. The gallbladder delivers a bolus of detergent, like bile, into our digestive system when we eat greasy, waxy things, and this allows them to be taken up into our bloodstream. Rats, on the other hand, aren't fortunate enough to have gallbladders. They can't absorb waxy toxins like fludioxonil when they are mixed with their food because of this. And most of the toxicity studies the EPA used to clear fludioxonil did specifically mix the toxin with the rat's food. As a result, when they were measuring toxic effects, it's very likely that 99% of the fludioxonil went straight through the rat's digestive system harmlessly, without entering their bloodstreams at any point. Frankly, I wouldn't consider this to be the best way to design a test. In fact, it looks rather like a system that has been engineered to have a loophole that corporate chemists could drive a truck through. On to my second point. My own research seemed to show that fludioxonil can cause chemical stress in target cells, creating aldehydes, free radicals, and depleting the protective molecule glutathione. Losing most of your glutathione is a bad thing. This is because a lack of glutathione sets your body up to fall prey to a wide variety of subsequent stresses, like other toxins, temperature stress, injury, or disease. These are stresses, by the way, that experimental rats in cages do not have to worry about. In other words, the primary system that the EPA uses to evaluate toxicity, rat studies performed to see how fast the toxin kills them, may be one of the worst ways to evaluate a waxy glutathione depleter like fludioxonil. In summation, I believe that the inventors of fludioxonil did a superb job of developing an incredibly poisonous pesticide that posed absolutely no health threat to lab rats. Now, there's a lot more to this story, but that's all for this clip. If you are interested, please check out the links below or check out the references from which our story is derived.